All right, chapter 10, section 3, using chords. So we're solving chords. All right, congruent corresponding chords theorem. What this is, it means in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if and only if is super important to know. What this means is if I have two congruent arcs, so looking at these arcs right here, here are my arcs. Oops, did not mean to put that in a pen. Here are my two arcs. AB is an arc and CD is an arc. If these arcs are the same measures, then your chords are congruent. Okay, if they're the same measure, your chords are congruent. So arc AB is congruent to arc CD if and only if your chords are congruent. So looking at the congruency marks, if they're congruent, your chords are also congruent. Perpendicular chord bisector theorem. If a diameter, which we should know what a diameter is, if a diameter of a circle is perpendicular, so looking at it, if a diameter of a circle is perpendicular to a chord, so looking at the perpendicular line, that 90-degree angle, then the diameter bisects the chord and its arcs. So if you don't know what the diameter is already, which we should know, the diameter is the line that goes from one end of a circle to another through the center. If that diameter is perpendicular to your chord, then your chords are congruent as well as your arcs are also congruent. So it's written out here for you. If EG is a diameter, which we highlighted in blue, and EG is perpendicular to DF, then HD is congruent to HF, and your arcs are also congruent. So looking at this one, it's perpendicular chord bisector theorem. All right, perpendicular chord bisector converse. Same exact thing, you're just flipping it. So instead of proving that your chords and your arcs are congruent, I'm now proving that my diameter is congruent. All right, so looking at this one, if one chord is a perpendicular bisect to another chord, so here are my chords. If this is a perpendicular bisector to another chord, so there's my perpendicular symbol, that 90-degree angle, then the first chord is the diameter. Okay, we're proving that this is the diameter. So looking at this statement, if QS is a perpendicular bisector to TR, then QS is the diameter of the circle. So we're proving that it is a diameter. So before, for perpendicular chord bisector theorem, we proved that your chords and your arcs are congruent. For this one, we're proving that your diameter is your diameter. All right, equidistant chords theorem. What does equidistant mean? Equally distant, yes. So when you're looking at this, in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So you are proving that these two chords are the same if EF and GF are the same distance from each other. So if these two little chords right here are congruent, then your chords are also congruent. So if segment AB is congruent to segment CD, if and only if EF is the same measure as EG. All right, looking at the examples, we're going to go ahead and do A, B, and C. Looking at A, I'm just going to draw this. This is your 90-degree angle. This is your triangle. We need to solve for X and Y. So looking at it, just some things to look at. Normally on a test or quiz, it won't be drawn like this. It'll be more of a word problem, just so you're able to label it a little better. So if you're wondering where this 13 is going, this line right here is 13, and what is that line called? This is my radius. So what does this measure right here? That's also my radius, so what's the measure of that radius? 13, it's not changing. All right, another thing that we should know is this side right here is 5. I'm just labeling a little better so you can see it. And then how would I solve for x? Good, this is a right triangle. I'm going to go ahead and solve for x. So setting it up, solving, I'm going to have 5 squared plus x squared equals 13 squared. 5 squared is 25 plus x squared equals 169. Subtract 25 from both sides. X squared equals 144. How do I get rid of a squared? Good, square root it. And what's the square root of 144? X equals 12. So x is 12. What is y going to be? Good. The same as x, which is also 12. So when I'm looking at this question, x is 12, y is 12, and how did I know that those were the same? I used the perpendicular chord bisector theorem.
Wait, but which one we're using?
No, just so you could refer back to it. Oh, that green, you could barely see it. No. The date should be on Canvas. I have to go back and check. All right, looking at B, here's my triangle. This angle right here is 60 degrees. So what kind of triangle is this? This is good. This is a 30, 60, 90 triangle. This is a special right triangle. So I'm just going to go ahead and I'm going to redraw this. We need to solve for x and y. And then it also asks, find the measure of arc AB. So here is my 30, 60, 90 triangle. And I have to label what I know about a special right triangle. What's opposite of 30? No, opposite of 30 is A. Opposite of 90 is 2A. Opposite of 60 is A radical 3. So if this side right here equals 6, what would A equal?
3.
Good, all you have to do is solve. Divide both sides by 2. A is going to equal 3 and just label everything. This equals 3. This equals 3 radical 3. So I know my answer for x, 3 radical 3. And I know my answer for y, which is 3. Now, second part that they're asking me for. Right here. Find the measure of arc AB. Find the measure of arc AB. Please pay attention to this. Follow your radius. Okay, that one's a little crooked. Here to here. If this measure is 60, so let me use my little arrow. If this measure is 60 right here, and that's the angle for this right here, this little arc, what is this measure?
60.
Good, this is 60. Remember, your angle measure is the same measure of your arc. But they're asking us for arc AB. So what should this half be?
60.
60 as well. So what's the entire measure of arc AB?
110.
Good. 60 plus 60. I'm going to get 120 degrees as my arc measure. All right, remember your angle measures are the same measures of your arc. God bless you. All right, now looking at C, this one's the easiest. Save the easy for last. Here is my 90-degree angles. These are my congruent marks. All right, looking at it, they're equidistant. Okay, this is equidistant chords theorem. If this side and this side are equal, what would x be? Good. X is going to be 8. So what would y equal? 16. Good. That one was pretty easy. Your x was 8 and your y was 16. Just add them together. Questions?
It's not going to show it like this. It's going to be a word problem.
It would. Well, if it's like this, it would be a little neater. But the word problems are easier because if I'm giving you the points, you could label it yourself. Instead of having like all this information squeezed on there and you're going to get confused which one does this number go to. So it'll most likely probably be in a word problem form. All right, second example. Example number 2, find the measure of arc CD in the diagram. So they're asking just for this measure right here. However, looking at it, how would I solve? I need to solve for x first. How would I solve for x? Good. I'm just going to make them equal to each other because they're going to be equal. So I'm going to have 9x equals 80 minus x and solve it algebraically. Add x to both sides. I'm going to get 10x equals 8. What does x equal? Good. X equals 8. And then what do I have to do to solve for arc CD? Say it one more time for me, please. Good. 9 times my 8. And that's going to equal 72 degrees as my answer. Questions, comments, concerns on this one? Yes. Sorry? Okay. All right, questions on example number 2? That was pretty easy as long as you know that they're congruent, they're the same. Yeah.
Hey, didn't you say like the angle will always be the same measure as the arc?
Yeah, I was going to say, couldn't you just do 9x equals 90 degrees?
Okay, the angle from the center. The angle from the center of the circle. So when you're looking at it, it would be, if it was 90 degrees, then it would be from here to here. But because it's not in the center, it wouldn't be the measure of the arc. Good question. All right, in diagram of circle C, now they're telling us QR is the same measure as ST, which is 16. They're asking me to solve for CU. How would I solve for CU?
2x equals 5x minus 9.
Good, I'm still setting them up equal. So setting it up as 2x equals 5x minus 9. I'm solving for x. So subtract 5x from both sides of my equal sign. Negative 3x equals negative 9. Divide by negative 3. X equals what?
3.
Good. And now I just have to plug it in. CU equals 2 times 3, which is?
6.
Good. Questions, comments, concerns on this one? All right, please go ahead and submit your notes to Canvas. Thanks.